Okay, we have these symbols. It's kind of cute, but I'm going to explain it with letters. That's going to make a lot more sense, in my opinion. When something is reflexive, that means A is equal to A. So if you look at yourself in the mirror, hopefully it is you you're looking at. If not, that's going to be a problem. The second one, we did use this one before. Symmetric property of equality states the following. If A is equal to B, then I know B is equal to A. Okay, put a big star on transitive. Transitive is the most often used property. So if at some point on your next test, you end up not using transitive, maybe you made a mistake, okay? So the transitive states, it kind of sounds like law of syllogism, but it is transitive. If A is equal to B and B is equal to C, what repeated? B. So then I could say A is equal to what? Boom. Does that kind of sound like law of syllogism? Yes. Yep. And then our next one, we have substitution. I want you to box that word because I do want you to spell them every single time because of subtraction as well. So let's say I have A plus B is equal to C. And then I also tell you that D is equal to B. So let's see what was repeated that I can replace, because replacing is substitution. B is going to be replaced with what? D. So that means my conclusion is A plus D is equal to C. Good so far? Okay. So let's do some algebra and do two-column proof. And I want you to put a star somewhere on the margin and write the following. The first reason is always given. The first reason is always given. What that means is, reason number one here is given. Always, always. So on the test, if you leave reason number one blank, you're choosing not to take any partial credit, okay? Let's go ahead and put in our orders, 2, 3. Oh, that's a 3. And then we have 1, 2, and 3. So let's think about algebra 1. From step 1 to step 2, everything is the same except 2 disappeared and 8 became 4. What was the operation that happened? Okay, so let's actually divide them. And show the actual work so you don't mess up. So we know we did division property. Did I divide on both sides? So what do I need after property? Of equality. This is very, very important that I'm going to highlight. Please do not forget of equality. And if you want to put a little tiny little star by it, that would be nice. So then let's see what happened from step 2 to step 3. From step 2 to step 3, so x remained, 4 became 3, and 3 disappeared. What do we do on both sides? Subtraction. Can we abbreviate subtraction? Nope. So subtraction, property of what? Equality. So let's go ahead and box subtraction and rebox substitution. So when you're studying, you're going back and forth knowing that you have to spell them out fully. So these are just steps to algebra 1, right? Okay, let's try number 2 with the partner. Go. Talk to your neighbor. And I would number them first. Okay, did you guys show the work on the side?
Yes.
So we physically multiply by what? 5 on both sides. So So 2 times 5 is 10. So that was what operation? Multiplication, property of what? Equality. And then for the second one, 2x is the same, 6 disappeared, 10 became 4, so we did what? Minus 6. So that was subtraction. Do we abbreviate that? No. Subtraction, property of equality. And then 2 disappeared, 4 became 2, so what operation? Division. So we know div prop equal. Boom. So if you had that, give your neighbor a high five. Say, good job. I guess you're okay at math. All right, let's go on to the next one. Okay, on the next one, we know our first reasoning is what? Given. So this one's slightly different because on the first page, I filled out all the left side for you, right? But this one I did not. So I want you to box the proof part right here. This always goes last. Always the last statement. Last, S as in statement. So this is going to go at the very end. So let's copy. P minus 2L is not a 1. Divided by 2 is equal to W. Now for sure, for this one, we have to show the process. So let's see what's happening here. Y'all ready? Okay. Always look at the end result in the beginning to compare what's happening. So at the beginning, I had 2 components on the right, correct? At the end, do I have 2 components on the right? Which letter disappeared? The L. So maybe I need to do minus 2L. So compare and contrast. So that goes away. So I have remaining P minus 2L is equal to 2W. So what operation did I just do from 1 to 2? Subtraction. Subtraction property of equality. Okay, so then let's see what we need to do on the next one. The 2W, the 2 disappeared. For 2 to disappear, what do I need to do on both sides? Divided by 2. And do I really see what I'm expecting? Yep. So that was division, property of equality. So example 4 is kind of nice because there's only 2 steps. So we know this has to go where? The last statement. So we know C over 2 pi is equal to R. And we know our first reasoning is always what? Given. So the 2 blanks are already given to us. The last one is all that we need. So let's compare and contrast. So I see R on the right, but we do not see what? 2 and pi, right? So maybe we divide it by 2 pi. And do I actually see that on step number 2? Yeah. Yes, I do. And that was what operation? Division, property of equality. Okay, let's try the last one with the partner. Go. Talk to your neighbor. You can even talk to yourself if you want.
Actually, we have.
Okay,
We get like a number here. So I get S.
yes.
Oh, multiply by. Oh, I don't know if I see L.
It is an L.
Wait, I think you do minus B.
Can you separate P and L?
Not at the beginning.
Not at 2. There's just PL and then the side is.
No, let me see.
Oh, well then you divide by 2.
Okay, I'm going to give you a starting point. You need to subtract B on both sides. And that's going to go into our second statement. S minus B. is equal to half of PL. And that was subtraction property of equality. Okay, what is annoying about the right side of the equation here? The fraction. Let's get rid of the fraction. Multiply by 2 on both sides.
Okay, so.
Then we have 2s minus b is equal to PL. So that was what operation? Multiplication, property of equality. And then lastly, I'm not messing with the L, right? So I want to move the p by doing what? Divided by p. And do I actually see the remaining? So we know that would be division prop of equality. If you almost had that, still give your neighbor a high five. Ooh, I don't hear it a lot. All right. Okay, let's do example number 6. Okay, on number 6, we're missing the column. So let's go ahead and make them. We have our little, I have a ruler. You guys have an ID badge, right? I know. Those ID badges are so useful. And then it looks like it's 5 steps. It's actually 6. 1, 2, 3, 4, 5, 6. And then let's number the other side. 1, 2, 3, 4, 5, 6. What do you think I might add on to on the number 6 statement? X equals 5. Okay, let's take this step by step. What is our first reasoning at all times? Given. And then let's see what's happening next. NO is replaced with 4x minus 4. NM is replaced with 2x. MO is replaced. So I think I heard it. What was it? Substitution property. Should substitution property have equality? No, because did I do the exact same thing on the left and the right? No, I just plugged it in, okay? And then let's do some algebra 1. So let's compare and contrast. The left side is the same, right? The negative 9 is the same. So how did I get 5x? Combine like term. So let's write on here. We combine like terms. What was another word for that? Ooh, simplify. Simplify, yes. The next one. The negative 4 is the same. Negative 9 is the same. 4 disappeared. 5x became an x. What happened there? Minus 4x. And actually show the work. So that's going to be subtraction property of what? Of equality. So what operation are we doing from step 4 to 5? We are adding 9 on both sides. So that was addition property of equality. And we know our last one is what property? Uh-oh, it was on the front. If A is equal to B and B is equal to A, symmetric. Property of equality. All right, last page. Okay, the angle is the same thing with the segment addition postulate. It is redundant, so I'm going to move on to the following. And let's put a star number 8, star number 11, I don't know why, because I feel like it, and star number 14. Okay, so this is going to state what property to use, and then we have to figure out what's my final conclusion. So on this one, it says to use what property? So when I'm subtracting something, and we have not specific numbers, we're looking at something that looks identical. If I subtract ST on both sides, then we have remaining PQ is equal to what? Boom, done. So I'll ask you to perform the operation and then write the remaining. The next one, what property it says? So what am I going to divide on both sides? Okay, divided by 3. So that means measure of angle A must be how many degrees? Done. Okay, number 10, what operation again? What are we going to subtract? 45. So that means we have remaining that measure of what? Angle 1 is equal to measure of angle 2. Okay, and then the addition property of equality. This one is kind of unique. I'm going to show you with the letters, and then I'll give you the actual example with numbers. Good? So let's circle the first piece and add them. Mn plus AB. It's going to equal what plus what? RS plus CD. And if you're like, well, I need a concrete example, I'm going to give that to you. Is 2 equal to 2? Okay. Is 3 equal to 3? Okay. So Mn is 2. AB is 3. RS is 2. CD is 3. Is that statement true now? Yeah. All right, let's try 12, 13, and 14 with the partner. Go. Go back to the first page on the first 4 things.
This is reflexive. Oh, yeah.
I heard some of you guys say reflexive property of equality. Notice the symbolic notation. It'll be reflexive property of congruence. It has to match. So if it's got equal, you say equality. If it's got congruence, then put that in place of the equal. Okay, what property is number 14? Transitive. So AB is congruent to CD, and that same CD is congruent to EF. Therefore, AB must be congruent to EF. Transitive property of congruence.